Greetings and welcome, friends. Mr. Waddy here. We are doing it, friends. We are doing some algebra today. We're going to solve some equations. We're going to know what x is equal to. It's going to be amazing. I can't wait. But here's some vocabulary first. It says this. So we're going to solve linear equations by adding or subtracting, and then later using multiplying and dividing. It says an equation is a statement that in which two expressions are equal. So we've talked about expressions. They can have variables and operations and numbers. But now I'm going to throw in this piece of equal, right? So an equal sign will be between them. A linear equation in one variable is an equation that can be written of the form ax plus b equals 0. All right, so my variable is x, and then I've got some non-variable parts being the a and the b. So these would be, a and b are going to be actual numbers, and then x will be some unknown variable for us. And it says a solution of an equation. All right, so lots of stuff. So I'll have an equation, right? Linear equations are of the form ax plus b equals 0. And a solution is any number, any value that makes that equation true. So I'll find out whatever x equals that would make this equation true is what we're going to deal with. Now, the tactic through which we're going to solve today, because sometimes if I gave you an equation, for instance, let's say I gave you this. What if I said x plus 1 equals 2? What would go in the place of x? What plus 1 is 2? You'd be like, oh, Mr. Waddy, x equals 1, and because if I plug 1 in there, 1 plus 1 is 2. And I'd be like, yeah, you're right. And that guess and check, fill in the blank strategy will work for you sometimes, but will fail you in the long run. So today we're going to solve using what's called inverse operations. All right, where we're going to undo the thing that's happening to x. All right, and inverse operations are two operations that undo each other, such as addition and subtraction, right? Adding and subtracting they undo one another. All right. What's another pair of inverse operations? Adding and subtracting undo each other. Multiplying and dividing are inverse operations. And then even if you're fancy, you could say that squaring something and square rooting something will be inverse operations. And when you perform the same inverse operations on each side of an equation, you produce what's called an equivalent equation, and those have same solutions. All right, so let's get to solving rather than some of this vocabulary. The first skill we're going to learn is called the addition property of equality. And this is the idea. If I have an equation where two things are equal, I can add the same thing to both sides, and it'll still be equal. All right, that's all it's saying. Just like when we were talking about apples and oranges and balance scales, right? If I add an apple to both sides of the scale, it maintains its equality. All right, and the same thing with subtraction. If I take away the same thing from both sides of an equation, it doesn't change its equality. You can take the same amount from both sides without changing whether or not it is equal. So let's look at example 1 here, and I'm going to show you this technique, and I'm also going to show you the way to properly communicate about the math. So our work is going to be significant, all right? I believe many of you guys could probably just figure out the solution right away, but I need you to also know how to write it so that in a world of mathematicians, you can communicate effectively. So here's my first equation. X minus 3 equals negative 5. Now, what is the inverse operation of subtraction? What's the opposite of subtracting? Addition. So to get x by itself, I'm going to use the inverse operation of subtracting. I'm going to add 3, and I can't just do that willy-nilly on this side because now it's no longer equal. I have to add 3 to both sides, and I'm going to write this plus 3 right underneath the other constant, right underneath the other number, and I'm going to get x. Negative 3 and 3 add to be 0. You could write plus 0, but why would we do that? We don't need to do that. I line up my equal signs. So when I'm solving, my equal signs stay lined up. And 3 and negative 5, their signs are different, so I subtract them, I get 2. And who was more influential? The 5, yeah. So it's going to be negative 2. So I get x equals -2. And the reason I was able to make that move was using the addition property of equality. All right, I can add the same number to both sides of an equation and it maintains its equality. Now they ask me to check your answer. Now to do a check, that just means I'm going to take this and plug it back in the original equation for x. So let's see if this makes sense. Is -2 minus 3, so I'll write CK for check, is -2 minus 3 equal to -5? And when I do this check, I don't use algebra. I don't add or subtract to both sides. I'm just going to use order of operations. -2 and -3 combine to be -5. And hey, -5 equals -5. It makes the equation true, and therefore, -2 is a solution of the original equation. All right, so when solving, my goal is to get the variable by itself by undoing everything that happens to it originally. All right, so let's look over here. This one's a little weirder. It's got some decimals, but don't let it scare us. I'm already scared. It's okay. Whew. All right. Y plus 2.8. I'm looking at over here. I want to solve for y. So I'm going to try to move this plus 2.8. What's the inverse of adding 2.8? I've got to subtract 2.8 from both sides. And let's see, I'm going to get 0.9 minus 2.8 is -1.9. You could reach for a calculator for that. I keep my equal sign. Notice how nicely lined up my equal signs are. And on the right-hand side of the equal sign, I'm left with plain old y. Now, this is written in a way that's kind of like the way Yoda would solve an equation. -1.9 equals y, right? I like to put my variable on the left side, so I'm going to switch the whole thing around. I'm going to just say, let's say y equals -1.9. That's a much better way to say it. And so let's say how I did this. So the technique I used, I subtracted something from both sides, so that's the subtraction property of equality. And then when I flipped both sides, this is actually called the symmetric property of equality. Or just symmetric property, right? If B equals A, then A equals B, right? Equality works both ways. And let's see, we'll skip the check for now, just so I get to some more interesting problems. Let's look at these problems 1, 2, and 3. These are what are called the monitoring progress questions in our book, but you guys have them already written in your packet. All right, so here's 3 more equations. I'm going to solve using inverse operations. All right, I'll do this one here. N plus 3. What do you guys think I could do to both sides to get n by itself? Yeah, -3 minus 3, both sides. So that's the subtraction property of equality. I'd be left with n by itself, equal sign, line it up, and -7 minus 3 is -10. So I just solved. I got the variable by itself using the subtraction property of equality. All right, cruising right along. Tracking with me here, Devin? The opposite of subtracting a third would be adding a third. Right? And that's a fair play. I can add something to both sides and it'll still be equal. So I'm going to get G equals, because, right, these just canceled out. Actually, if you want, you could even write that part where you're like that cancels, right? Just to like verify, oh, G is definitely by itself right now. And, ooh, tricky. -2/3 plus a third. The answer is going to be in thirds. What's -2 plus 1? -2 plus 1. The signs are different, so I subtract them. And then the more influential one was the negative. So I get G is equal to -1/3. A little bit of fraction work there. So let's see. Over here, to get the variable P by itself, it's currently being added by 3.9. So how do I get rid of adding 3.9? How do I undo that? How do I undo addition? What's the inverse operation? Subtraction. 3.9, both sides. Yeah, anyone was going to answer just to get me to stop singing. Subtract 3.9 both sides. That's fair game. It's still going to be equal. And let's see. I'm going to get subtract 3.9 both sides. I would reach for a calculator there possibly. It's going to become more negative. And I get negative 10.4 is equal to P. Well, let's put the P on the left side here. So that's the same as P equals negative 10.4. And the property I used was the subtraction property of equality. That I can take something away from two sides of a balanced equation and it will still be equal. Now, those are not the only tricks that we will learn today. Turns out you can also multiplicate. I don't think anyone ever says it that way. All right. Here's a big idea. If A equals B, then I can multiply both sides by C, and it'll still be equal. All right? They tell me don't let C equal 0. Like, that's not the most helpful. Right? Yeah. And then similarly with division. Division property of equality. If A equals B, then A divided by C is going to equal B divided by C, as long as C is not equal to 0. In that case, it matters a lot because dividing by 0 just breaks the universe. It doesn't like that. I don't know if you guys knew that or not. It's just bad news for the universe. Okay, so we can use multiplication and division. Right? So punch, kick, block, right? Roundhouse, all sorts of things. You guys are learning how to like fire bend over here. Pretty awesome. Yeah. But we're getting there. I'm going to train you guys. You guys are going to be like the Avatar. All right, so here we go. What is happening to n over here? N is being divided by 5 and then multiplied by a negative, I guess. I could also imagine that as being n being divided by negative 5. What's the inverse of division? What's the undoing of division? Multiplication. So if I multiply by 5, that would undo dividing by 5. And watch this, better yet, let's multiply by negative 5, because this minus sign and this minus sign are going to cancel out. Right? And so I can't just multiply this side by negative 5. I have to multiply both sides by negative 5. So I could write that over here. Or if you want to write it over here, be cautious. If I write negative 5 over here, it looks like I'm saying negative 3 minus 5. You might need to make sure you throw that in parentheses so you know you're multiplying and you ain't subtracting. All right, so watch how cool this is. Ready? We're going to solve for n super quick. The 5s canceled out. Those minus signs cancel out. And I get n equals, my equal signs line it up, negative 3 times negative 5. Negative times a negative is a positive. And 3 times 5 is 15. All right, so using inverse operations, I'm getting the variable by itself. All right, does anyone know what this little thing is? Yeah, that's pi, right? That's related to the circumference and the diameter of any circle. Pi is just a number, right? It's like 3.14159. Yeah, what do you think I could do? X is currently being multiplied by pi. So the inverse of multiplying by pi would be to divide by pi on both sides. And then, yeah, these cancel out. And watch how cool this is. Over here, I simplify as well. Like Amity was saying, I can cancel out those pi's just like I did on Thanksgiving. And I get x equals negative 2. All right, so the inverse of multiplying by pi is divide by pi. You can divide by whatever. All right? Except 0. All right, over here, what's happening to z? Z is being added by 1.3. Is it being subtracted by 1.3? No, z is being multiplied. How do I undo multiplication? Yeah, divide both sides by 1.3. The 1.3's cancel out. I'm going to get z is equal to, that I believe is 4. All right, so I can use inverse operations. This one was the multiplication property of equality. These two were the division property of equality. I can do the same thing to both sides of an equation, and it is fair game. All right, it's all good. Oh, man. No, not even close. Not even close. All right. Let me do these ones fast. Don't write these down. Just think about the process, okay? All right. Y is being divided by 3. The inverse would be to multiply. I can't just multiply this side by 3. It'll not be equal anymore, so I multiply both sides by 3. I get y equals 3 times 6 is 18, and I've got that minus sign still hanging out, negative 18. Over here, x is being multiplied by pi. The inverse of multiplication is division. Divide both sides by pi. I'm going to get, those pi's cancel out. I'll get 9 equals, those pi's cancel out, x, and better yet, x equals 9 when I flip it around using the symmetric property. All right, over here, w is being multiplied by this crazy decimal. Let's divide both sides by that crazy decimal. Right? And watch what happens. This cancels out with that. I'm going to get w by itself, which is what I wanted. I get w equals whatever 1.4 divided by that crazy decimal is, which apparently is 28. Yeah, like how many nickels fit into $1.40? 28 nickels, apparently. All right. Last type of problem that I'm going to show you. Let's see. And it's a problem-solving strategy, which I call VESA, V-E-S-A. All right, so if I have a word problem, VESA, like a mesa, I don't know. This is the way that we're going to try to do things in general. All right, the first thing we do for a word problem is define the variables, okay, including units. All right, so sometimes I'll have an x and a y or a t for time, whatever. I'm going to define variables after I read the word problem and try to figure out how I can set it up. All right, and pro tip, your variables will often be whatever they're asking. Right? At the end of a word problem, they'll say, how many basketballs did the team buy? And then I'd be like, oh, they're looking for the number of basketballs, huh? I'll let my variable b equal the number of basketballs. And then you literally just take the question, and that's the thing you're looking for. So that'll be a great variable. The next thing we would do is write an equation using those variables and the facts found within the problem. So you might be like, oh, the team bought 8 more basketballs than footballs, right? And then you have a little fact, and you can write an equation relating the variable and some other numbers. And then we're going to solve our equation using algebra, right? Add things to both sides, subtract, multiply, divide both sides, whatever. And then at the end, we write an answer, which is a sentence answer, okay? Sentence answer. And I'll end up with like b equals 12 or something like that, right? And if I said b up here was equal to the number of basketballs, right, number of b-balls, then my answer is just going to be combining 12 and this. So I would say they purchased 12 basketballs or something like that. All right, that's the general strategy, okay? That's what we're going to end up doing. Let's look at example 4. I'm going to skip example 3, and this will be the problem that we do. I think I like this one better for the concept. All right, here's a whole bunch of words and numbers that they're giving us. Example 4. So you guys write this down. Make sure you get the process. We're going to have a VESA. VESA. So starting with V. It says, on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? Now notice, when I write my variable, it's literally going to be related to the question they're asking. How many degrees did the temperature fall? Let's make a variable x equal to the number of degrees the temp fell. And what unit is that measured in? Well, these are all talking Fahrenheit. So yeah, so let's talk about this in terms of Fahrenheit. All right, so I define my variables. And now I'm going to write an equation using that variable. Let's see, it fell from 54 to negative 4. So my equation is, when I had 54, and then my temperature falling is going to be, well, if it fell by that, it's negative. It subtracted the number of degrees it changed by. And that should equal what? And negative 4, right? And we literally get that just from, so it fell from 54 to negative 4. I didn't need to know the time. I didn't need to know the date. I didn't need to know anything about Spearfish, South Dakota. I just needed to write an equation using this fact. Okay? And now I can solve that equation. Now this is tricky. X is not being subtracted by 54. 54 is positive. X is the thing that's being subtracted. So to move the 54, how do I move a positive 54? How do I undo a plus 54? Subtract 54 from both sides. And I'm going to get the opposite of x is equal to, that becomes more negative, that's negative 58. So guys, if the opposite of x is negative 58, what do you think the positive of x would be? Right? If I change the sign here, I can change the sign there. I'm going to get x equals 58. All right, just like when we were dealing with algebra tiles and I said, oh, negative x equals this, and I just said, well, just flip it, right? Just change it to a positive x and then change all the signs on these ones, and that's how we can do it. If you wanted to think about algebra justifying that, you could think of divide both sides by -1. You could multiply both sides by -1. I just say opposite everything. What do you think, Jimmy? I'm assuming so. I'm assuming so. And now the last thing I need to do is answer the question, right? They said, how many degrees did the temperature fall? And I can combine 58 with this, right? The temperature fell 58 degrees Fahrenheit. Bam, sentence, done. Drop the mic. Have a good day, internet friends.